Hi everyone. So we have studied binary ripple counter. Now we are going to study non-binary ripple counter. Okay, so it is non-binary ripple counter. What do you mean by that? Here we will be using clear and preset input. So previously we were making mode 2 to the power n counters, right? Mode 4 counter, mode 4 we made, mode 8 we made, mode 16 also we made. But now in between whatever the number is there, we can make mode 7 counter now, mode 6 counter, mode 14 counter, mode 13 counter. So the number of states will not be equal to 2 to the power n, it will be lesser than that. And for that we will have to use clear and preset input, clear or preset input. And we have already studied about these inputs, so now we are not going to study about that. So already we have studied, right? So counter will not count all the way up to 2 to the power n or all the way down to 2 to the power n. So what we will do, this will be the simple binary ripple counter that we have already studied, binary asynchronous counter. The outputs, these are the outputs, okay? This could be Qn, this could be Qn minus 1, and this could be your Q naught, which I am calling as LSP, and this I am calling as an MSP. That doesn't matter here. So these outputs will be fed to a combination circuits, and the output of the combination circuit will be clear or preset. Got this point? Okay, so we will see the circuit, it will be more clear to you. And one simple node is there, one very simple node. So this is an inverter I have connected here, inverter. Now if I need to make it something like this, that this inverter is gone now, this input is A only, okay. Now I need to carry this inverter in these loops. So how will I carry that? In these branches. So this is how I will carry that now. How did I come to this conclusion? Look, if this is A, this will be A bar. So this all will be A bar only. If this is A, this is A bar. So all will be A bar only. If this is A, so this will be A bar only, because A will travel here, A bar. So final output did not change. Now this can be fed to any other circuit here, like any other circuit could be there, any other circuit could be there, any other circuit could be there. Both will get A bar only. So basically, just if I need a bubble to travel in the branches, then it will be distributed like this, no? This bubble will be distributed like this only, right? So it's not that only in one branch the bubble will go. The bubble will go in both of the branches. So that's a simple note I wanted to give. So let's start our chapter now, or we should say let's start our topic now. That is, you need to design a mode 5 down counter considering all states are set. Initially all states are set. So first see the solution, then next question you can solve on your own. So what is the thing? You need to design a mode 5 down counter. Mode 5 ripple down counter, here you should write. We are studying ripple counters only, asynchronous counter, or you can write asynchronous counter. First see this important point, the initial states are set. What do you mean by initial states being set? That means all states are at 1 1 1 1. Then from here you are designing down counter, so you will go to 6. You need 5 states, right? 4 6 5 4 3. That's it. This will be your last state, because you needed 5 states. So 5 states you are having. So this is your mode 5 down counter. Okay, before that I forgot to explain one thing. Mode 5 down counter. So before this step, one more step will come. How did I know that there will be 3 bits? How did I know that there will be 3 bits? So this is mode 5. That means how many number of states you want? Number of states. Mode 5 means there will be number of states 5. So you need 5 states. So for n equals to 1 you can get 2 states only. N equals to 2 you can get 4 states only. N equals to 3 you can get 8 states. So yes, this can be used. So basically your 2 to the power n should be greater than 5. So your n should be greater than log 2 5, whatever the value it is, your n will be coming out to be 3. 2 to the power n should be greater than 5, or equals to also could be there. So n should be greater than equals to this number. Okay, so n is 3. So you would need at least 3 bits. You would need at least 3 bits to get 5 states. If I were using only 2 bits, then I would go to 1 1, 1 0, 0 1 and 0 0. So only 4 states I can get, but I need 5 states, then certainly I need to use 3 bits. Okay then. And if I want 3 bits, that means I need to use 3 flip-flops. If I want 3 bits in my output, then I need to use 3 flip-flops. So there will be 3 flip-flops, and this is how it will be going: 1 1 1, 1 1 0, 1 0 1, 1 0 0, 0 1 1. So what is the usual counter we have studied? That it goes from 7, this is your 6, then 5, it will keep on going. 5 I can write all only, then 4, 3. After that you don't want 2. You don't want 2. This was your 2, right? After that you would come to 2, but you do not want this. You don't want this. You again want to go here. So what do you think what you need to use? Preset input, right? Because what preset input does? What preset input does? Preset input will take all the outputs to 1. So no matter whatever the previous state was, it will take all the outputs to 1. Are you getting this point? Right? So first I will design a simple counter. This is a simple counter. Now I have these outputs, right? I have these outputs. So I wanted my 1 1 state to come. Okay, yes. I wanted my 1 1 0 state to come. Yes. Nothing I am doing in the circuit. I was starting from 1 1 1. Okay, I wanted it. Then I got 1 1 0. I started it. This is a down counter, right? Plus plus. Plus plus is there. Plus plus repel each other, go down. Plus plus repel each other, go down. I hope you remember this trick. Okay, plus plus is there, then go down. Because a lot of people in longer run, like when you study other subjects, you will forget this thing, that when you get down counter, when you get up counter. So plus plus repel, go down. Plus minus attract each other, go up. If you are attracted by 2 people, that means you are going up in your life, right? 5 I need, 4 I need, and 3 I need. So these I need. This counter next will give me 0 1 0. This is what this counter will give me. Just as I was getting here 0 1 0, just as I was getting 0 1 0, what I will do, I will take these outputs, which are Q0, Q1 and Q2, and will give it to a combinational circuit. Will give it to a combinational circuit such that it gives output F equals to 1 here. F equals to 1. If this preset is being, now this F will be connected to preset. This F is preset only. Now this preset, if this preset is 1, just as you got 0 1 0 here, just as you got 0 1 0, at that time only I will apply, I would have designed this combinational circuit. Just as I give 0 1 0, I will get F output 1. This will be active, and if this is active, then all will be reset. All will be set. All will be set. Right? Are you getting this point? 0 1 0. I wanted 0 1 0. So I will design my combination circuit such that for this it will give me 0. 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 Preset is 0. So nothing is changing. Just as I wanted 0 1 0, at that very time it will become 1. Just as will become 1, all the outputs will be set. Because what is the job of preset? It will make all the output to set. So from here to here, all outputs will be set. So your pre should be equals to 1 here. If your pre is 1, then all outputs will be set. Are you getting this point? Okay. So what will be this combination circuit? Can I write this combination circuit as Q0 bar, Q1, Q2 bar? Very easy, right? For all these, you are not going to get this as equals to 1. That's for sure. For all these inputs, put here this was your Q2, this was your Q1, this was your Q0. So if you put Q2 equals to 1 here, you are going to get it 0. For this condition, Q2 is again 1, you are going to get it 0. Here Q2 is again 1, you are going to get it 0. Here Q2 is again 1, you are going to get it 0. In this case, Q2 is 0. Q2 is 0, so this will be 1. Q1 is 1, this will be 1, but Q0 is also 1, so this will be 0. But in this case, 0, Q0, Q2 is 0, so this guy will be 1. Q1 is 1, this guy is also 1, and Q0 is 0, so this guy will also be 1. So this will become 1. So in all these cases, this was not becoming 1, but just as you got this thing, then it would become 1. So what you are going to do? So F you are getting as this. So what you are going to do? You will take these outputs, you will take the pins of these outputs, okay? Then one inverter, one goes as it is, then another inverter. So these pins I have taken out, then I will connect it to a AND gate, okay? And the output of this AND gate I will call as pre, okay? So better what I can do here, I will call this as pre, and this is my AND gate. And how I am getting the input of this AND gate? So this is being inverted, Q0 is being inverted and is fed here. What about Q1? Q1 is coming as it is. Q1 will come as it is. So Q1 is coming as it is. And what about Q2? Q2 will also be inverted and will be fed here. So here you are feeding Q2 bar, Q1 as it is, and Q0 bar. And this will be 1 when pre will be 1. Pre will be 1 when Q0 is 0, Q1 is 1 and Q2 is 0. Now people will have the doubt that sir, 0 1 0 is coming, at least 0 1 0 is coming, this condition is at least coming. I do not want this state, but this is at least coming, but we are considering 0 delay here, okay? We are considering 0 delay here. Just as it came, preset was active, so it was there for a very minute time. Even if you consider TD delay of this gate, so it will be there for TD time. Certainly 0 1 0 would come, so TD time this gate will take. This take will take TD time to take this output equals to 1. So certainly it will take TD time, but it is not there for the complete cycle. The clock cycle should be large enough that it is not there. 0 1 0 should not be there for the last cycle. I know like some people will be having the doubt that sir, 0 1 0 is at least coming. No, yeah, I am saying that 0 1 0 is coming, but it is not there for the complete cycle. So we cannot say that 0 1 0 is there in your final output. No. If it was there for the complete cycle, then I could have said, okay, yeah, 0 1 0 is there in my output, so I can accept that. Are you getting this point? Do you agree to my point? What is the point? That you may have the doubt that sir, 1 1 is coming, 1 1 0 is coming, 1 0 1 is coming, 1 0 0 is coming, 0 1 1 is coming. After that, 0 1 0 is coming. At that time, this gate is becoming active. This is becoming active and pre is becoming 1. So yeah, that point I agree. But even if it is having some TD delay, then after TD time, this pre will be 1. And pre does not wait for the clock because it is asynchronized. So pre does not wait for the clock. Immediately it will send the output to 1. Immediately it will send the output to 1 1 1. So that condition was there for a very minute time. And that time is negligible. So we cannot say that 0 1 0 arrived. It did not arrive. Okay. So that was the scene. Now tell me one thing. This gate I have designed. Is it optimized design? Is it optimized design? Like, is this the best design? Like 3 inputs you are feeding to the gate. Is this the best design? No. Why it is not the best design? Think about it. Take your time and think about it. Why this is not the best design? You thought of this condition, 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 you thought of this condition. But what about these guys? 0 0 1 and 0 0 0. You did not even thought about this. So is it an optimized design? No. Look, these inputs will not even occur, right? These inputs 0 0 1 and 0 0 0 will not even occur. If these are not even occurring, then what they will be? They will be don't care. So now we are optimizing our pre-input. We are optimizing our pre-input. So for 1 1 1 it should give me 0, for 1 0 0 it should give me 0, 1 0 1 it should give me 0, 1 0 0 it should give me 0, 0 1 1 it should be 0. Just as 0 1 0, so here we are getting 5 states, so this will be my mode 5 counter. This will be my mode 5 counter. There is no doubt about it. But just as I get 0 1 0, so my this gate will become active and will give me pre-output as 1. Pre-output as 1. So at here 3, this is my 3. This term is 3. This term is not 3, sorry. This term is 2. So 2 at 2 my pre-output should be 1. And 0 and 1 are my don't care. 0 and 1 are my don't care. Here you are 0, here you are 1, 0 0 0 1 1 1 1 0. Right? 2 is 1 and 0 and 1 are don't care. So I can see that this is what I am getting. So this don't care I am using now. So what will be my final pre-state? That would be 0 0 is there, like 0 0 is being repeated. So q1 0 0 is constant here, q1 bar, and what else is constant? q3, q1 bar q3. Let me check it again. q1 bar q3 bar, sorry, this is q3 bar, this is q1 bar. So not q1 bar, q naught bar, sorry, q naught bar q3. This guy and this guy is constant, q naught bar q3. So this is your optimized gate, optimized design. Okay, this is your optimized design. So basically you will take those outputs. So instead of using 3 input gate, I can use only 2 input gate. So without even caring of q2, I can give this. If you are using 2 input gate, then this design will be easier for you. Designing this AND gate will be easier for you, and designing this AND gate is easy, then it is good for you, right? So this is, yeah, that's it, and this will be your pre-output. Okay, let's add up a page. Okay, let's add up a page, let's discuss it more. So this is my final design, which is this. Here you are getting pre, right? This was your q3, not q3, how q3? q3 is not even there. What I'm doing, q2 it is, q2. Okay, q2. So q2, this is q2 and this is q naught. This is your final design, q2 and q naught. And this was your pre-input, which was going to 3 flops. This was being fed to 3 flops, right? Pre, you can see this pre-input was fed to 3 flops. What if instead of this design here, if we had one bubble here, if my pre was active low, if my pre was active low, if my pre was active low, so generally in the examination, if active low is there, they will write it as pre bar. Okay, so pre is active low. From there I got to know that it is active low. So I will use the same design, but I know that bubbles are used here, 3 bubbles are used here. And if I use the same design, basically if I use this one and I need to introduce bubble here, so what I can do, I introduce one bubble here and another bubble here. In one row only I need to introduce bubble. So if I introduce one bubble here, then here also I need to introduce the bubbles. Say yes or no? Because I told you one bubble will carry 3 times. So for this particular design, what will be your optimized design? This guy, right? So this is your design here, this is your design. But if I am introducing bubble here, that means another bubble I will have to introduce here, right? So this bubble will be travel to this guy. So this will be your another design. So this is your q2, this is your q naught. What do you see? This is your, what is this? This is your bubbled AND gate. This is your NOR gate only, no? So this have the other form as well. this have the other form as well. So the point here is, like, if I need to change the designs, can I change it just by introducing the bubbles? Certainly I can change it. Look, I did not do anything here on the pre wanted me to be 1 only. So yeah, I did not do anything here. I just changed this guy. I can change this guy, no? Q2 Q1. Now pre want me to be 0. What if pre want me to 0? What if pre want me to be 0? What if pre want me to 0? So if you are getting confused here, let's do one thing. Now I am designing this for pre bar. If you design it for pre bar means active low. If you design it for pre bar, which is active low, so at that time all these should be high, right? All these should be high, because if pre is 1, then if pre bar is 1, then it is not working. If pre bar is 1, then it is not working. If pre bar is 0, that means it is working. Here it will set the output. If this was pre bar, that means if pre bar is 1, it will not work. If pre bar is 0, then it will work. So here there will be bubbles. Here there will be bubbles. If you see bubbles, what does that mean? Then certainly that your pre bar, whatever the input is there, that should be 0. If that is 0, then these will work. So if that is 0, these will work. So if this was the case, then what will be your optimized design? So all these are 0 0 0. Sorry, here all these are 1 1 1, right? All these are 1 1 1. This will be 0. This will be 0. Say yes or no? This will be 0, right? Now what I am writing? I am writing min terms, right? Here I have written, I am writing max terms, sorry. In the previous case I was writing min terms. Now I am writing max terms. 0, don't care, don't care. So what will be my max term? So what will be my pre bar? Pre bar is becoming Q0 plus Q2. Say yes or no? Q0 plus Q2. So pre bar is becoming Q0 plus Q2. Is that the same thing here? So my pre bar is coming Q0 plus Q2. What was your pre? Your pre is, you can see, pre is Q2 plus Q1 bar. Say yes or no? And here if I introduce a bubble, then another bubble I will have to introduce here. If this is my pre bar, if I am introducing a bubble here, then another bubble I will have to introduce here. So this was my design. This was my design for pre only. And if this is becoming pre bar, that means one bubble is there. So another bubble I will have to introduce here. So this bubble, so this bubble was already there. This bubble was already there. If I am making pre bar, I have to introduce one bubble here, right? This bubble was like these bubbles have been introduced. So if these bubbles have been introduced here, then one bubble will come here as well. And this bubble was already there. So this bubble and this bubble will cancel each other, right? So these two bubbles will cancel each other. And what you are getting? You are getting the same thing, Q2 plus Q1 only. So your pre bar is Q2 plus Q1 only. So for anything I can design. Are you getting this point? For anything I can design. Just by saying that, just by introducing these bubbles will be very useful for you. If you have designed for pre and they are asking for pre bar, then simply introduce a bubble here, carry that bubble here. What is the final design you are getting? This is the final design you are getting, and this is your OR gate only. So pre bar is Q2 plus Q1 and pre is Q2 plus Q1 bar, right? Or you can write Q2 bar dot Q1 bar. But for pre, we will write in terms of max terms only. Okay, we will write in terms of max terms for pre. So this is the final answer, that this will be your design for pre. So a lot of times these kind of questions are asked. Like they will make a black box here, and which gate you should use. 2 input, which gate you should use? You should use 2 input NOR gate. You should use 2 input NOR gate, right? Okay then. Yeah, so just a small error I did here. This will be Q2 Q0, no, not Q1. Q2 Q0. Okay. So a small error is there. Q2 Q0. So this will change. This will be Q2 plus Q0 bar and Q2 plus Q naught only. Okay, so that was a blunder from my side. Now we will see a shortcut method, like how to write these expression without even doing this, without even making this table. So without even making this table, we can write down these expression. Okay, and with that there will be a special note as well that we will see. So when this method will be applicable. So what do you think? First, you need to design mode 5 down counter. Mode 5 down counter. Mode 5 down counter I am designing. So first question you will ask is that at what value of Q2, Q1 and Q naught my pre will be active? My pre will be active. So pre will be active where? Here pre will be active, right? 0, 1, 0. At 0, 1, 0. So directly I will see mode 5 down counter is that initial states are set. So 7 to 6 to 5 to 4 to 3. Mode 5 down counter it is. 2 I don't want. 2 I don't want. If I don't want 2, so my pre will be active at, when pre will be active, this is your Q2, Q1 and Q naught. So here pre will be active. Now one line I am telling that you need to remember. Okay. So for down counter, always look at 0. Always look at zeros. So first thing is that this is the first step. This would be second step. The first I will think when it will become active. So at 0, 1, 0. So Q2, Q1 and Q naught value is 0, 1, 0. Now I will look only at 0. So now I will design 3. If I am looking at 0, that means what I am thinking? POS or SOP? If you look at 0, you think of POS or SOP? POS. If you look at 1, you think of SOP. So I will think of POS now. So I need to write down there. This is a simple thing, like this I don't need to write because we have already seen it. If I think of 0, I need to think of POS. So now I need to write down pre-expression. So I will look at only zeros. In the POS term I will write Q2 plus Q naught. But I know one thing, Q2 plus Q naught, 0 plus 0 will give me 0. But I want my pre to be 1. So bar, there you go. This is your pre. And if you need to design pre bar, so same thing you will do, that when it will become active, then 0, 1, 0 is there, 0, 1, 0 is there, then you will only look at Q2 and Q naught. Now 0 plus 0 will give you 0 and this is what you want. For pre becoming active is 1. For pre bar becoming active is 0. So first thing, when it will become 0, sorry, when pre or pre bar will be active, pre or pre bar will be active at 0, 1, 0. Both will be active at 0, 1, 0 only. So in case of pre, I want my output to be 1. So Q2 plus Q naught. If I am writing Q2 plus Q naught and I want my output to be 1, right? I want my output to be 1. So if I want my output to be 1, so Q2 plus Q naught, 0 plus 0, then bar. Okay. And here 0 plus 0, I want my output to be 0. In case of pre bar, I want my output to be 0. So I will keep at 0 only. So this is my pre bar and this is my pre. Otherwise you can do the optimized design, but this is a shortcut method that you can follow. Okay then? Yeah. So, but very important point, very important point, and a lot of times this point is missed by a lot of students and even by the teachers, that this method that I told, this method will everyone will tell, but this method will be applicable if your initial all states are 0. Sorry, initial all states are 1. So if you are starting from the max value, look, if you are designing down counter, you need to come down, right? You need to come down. So where you will expect yourself to start? From the maximum. If I need to come down, if I am designing down counter, so I will expect myself to be at 1, 1, 1, no? Then I will go to 1, 1, 0. Then in that manner I will go, right? So for this particular expression, it will be applicable. This method will be applicable. But let's just say if I am starting from 0, 0, 0. So if I need to count down, then from 0, 0, 0 to I will come to 7, then I will come to 6, then I will come to 5. In that manner I will go. So here this method will not be applicable. Or let's just say pick any state, which is 5. This is 5. So 5 to 4 you will go, 4 to 3 you will go, 3 to 2 you will go, what is 2, and then 2 to 1 you will go, and then you will come back. So this is also your mode 5 down counter only, mode 5 down counter. This is also mode 5 down counter. The same kind of counter is there, but here it will not be applicable because you are not starting from maximum. So if you are designing down counter, that means you are expected to start from the maximum value, and then only this method will be applicable. Okay, otherwise you will have to do the complete this method that I told, that will be applicable. Otherwise you will have to make the table and get the output. Okay, so now let's see this question. Here the trick will not be applicable, and why it will not be applicable, that we will see. Okay, so you need to design mode 5 down counter considering all flops are initially reset. All flops are initially reset. Reset means this is the initial condition, and then you are going to what? Then you are going to 1 1 1. From 0 to, if I go to 1, that means it is counting up. I need to count down, that means I need to go to 7, right? From 0 to 7, then I will go to 6, then I will go to 5, and then I will go to 4. So this is what I am counting down. 5 states are there. This is your mode 5 down counter. Mode 5 down counter. So if I apply that trick, this trick that I told you, if I apply that trick, then what I would do, that which state I do not want, which is the first state I do not want, that is 3, right? That state is 3. 1 3 is 0 1 1. This is your 3 3 0 1 1. This state I don't want. So what I told you, and yeah, second thing is that here you will design pre or clear. Here this will be your circuitry where initial states are 0 0 0. So you are going from 0 0 0 to 1 1 1 1 1 0 1 0 1 and 1 0 0. After that, what you need to do? You need to clear your output, right? You need to clear your output. So here I am requiring clear signal. What clear will do? Take all the outputs to 0. So here I will require clear signal. Are you getting this point? So here I am starting from 0 0 0, then I am going to 1 1 1, then 1 1 0, 1 0 1 and 1 0 0. And then I need to clear my output. Did you understand this point? So here I will design clear input. So for down counter, what did I tell you? For down counter, always look at 0. So if I design my clear input, for down counter, always look at 0. Okay, Q2 I am looking. I need my clear to be high. So Q2 is 0, high. This is wrong. Okay, 95% of the students will design in this manner only. Okay, down counter, you need to look at 0, then Q2 bar, wrong. Why is that wrong? Because you are not starting from the maximum one, you are starting from 0 0 0. So let's design it using the exact analysis. So this is how we will design it. For 0 0 0, you need it 0 only, 1 1 1 1 1 1. So this is your mode 5 down counter, right? For 0 1 1, you need it to be 1. You need clear input to be 1. For rest of the time, you need it to be don't care. Okay. So this is your 3. This is your 3, which is 1. And 2, don't care. And 1, don't care. 0 also don't care. No, at 0 you want clear to be 0. Okay, so this is 0. At 0 you want clear to be 0. Now what I am getting? This is your 0 0 0 1 1 1 1 0. This is 0 1. So I can take either this don't care, or I can take this don't care. Both I am not taking. Basically my clear will be either here what is constant. Here this is Q2, yeah, Q2. Again and again I do the same error, I write it Q3. So here what is constant? If I take this one, if I am taking this pair, then what will be my answer? That Q0 is constant and Q2 bar is constant. Or if I take the green pair, because both are possible, so that answer would be Q1 is constant and Q2 bar is constant. So this is my correct answer. Okay. So either you make this design, basically you take Q0 and take Q2 bar. So either you make this design or you make this design. Q0, Q2. Okay. Q1, Q2. So these designs are correct. So this is your clear. And if you wanted clear bar, then add a page. If I wanted clear bar, so this is my clear. Let's take, I am taking this as forward now. Okay, both are possible, but let's take this one. Clear. Q0, Q2. Q0, Q2. And if I want to add a bubble here, if I want to add a bubble here, so this bubble will be added here as well. So this could also be one of the possible answer, but this will be the answer for clear bar. Okay. Q0, Q2. Therefore, here if you are getting using this gate, then here you can use this gate. So that would be the answer for clear. So for answer for clear is Q0, Q2 bar or Q1, Q2 bar. Right, Q1, Q2 bar. So here you can apply Q1 as well, and here you can apply Q1 as well. And what will be the answer for clear bar then? Clear bar would be Q0, Q2 bar, which can be written as Q0 bar plus Q2, right? Or Q1, Q2 bar, which can be written as Q1 bar plus Q2. So this thing like clear and clear bar is confusing a lot of times, but we have seen that if I am introducing a bubble here, then another bubble I will have to introduce. So just the bar of this we are doing. Okay, I could have designed this using this table as well. If I had designed using the table, then what would be the scene? If I had designed using the table. So let me copy the table. Yeah, it is copied. Then what I need to design? Clear bar. I need to design clear bar. So what I am going to do? I'm going to erase all this. So this is my 3 only. For clear bar, all these should be 1, 1, 1, 1, 1, and then this should be 0, and these are don't care. So this should be 0, and these are don't care. Okay. So 2 you can take again. This guy you can take, or this guy you can take. Here what do you do? You wrote the max terms, not the min terms. So what will be your clear bar? You wrote the max terms. So max terms. So here what is constant? 1, 1 is constant. That means Q0 bar is constant. Plus what is constant? Q2. Or here in this case 1, 1 is constant. Q1 bar is constant plus Q2. So the same thing you are getting here. Q0 bar plus Q2. Q1 bar plus Q2. Right. So how you can make it? Basically you can make in this manner as well, that this is Q0 bar. So whatever the options are there, like there could be MSQ as well, that this is also a possible design, Q0 and Q2. So and this will be your clear bar, right? This will be your clear bar. There you go. Are you getting this point? Okay. So a lot of possible designs are there. Just the thing is you need to think in the examination what you need to design, and here there is no shortcut applied. So let's solve a problem now based on the previous analysis that we have done. Okay. So you need to design a mode 12 down counter, and you need to optimize your pre or clear input. Whether you will use pre or clear, that is based on you. So first step, mode 12 I am using mode 12. So how many flops you require? You should tell it on your own. How many flops you require for mode 12? 4, right? Because with 3 flops you will get 8 states only, but with 4 flops you can get 16 states. So you require 4 flops. Basically there will be 4 bits, and I need 4 flip flops. Okay. Now consider all initial flops to be set. Now the first question, initial all the flops are set, then all are set, that means this is the maximum. And what you are designing? You are designing down counter. Down counter. If you are designing down counter, that means you are expected to go down from the maximum value. You are designing down counter, that means you are expected to go down from the maximum value. So you are going down from 1111 to 1110 to, in that manner you will go. This is mode 12 counter. So basically you will start from 15, then you will go to 14, then you will go to 13. Which will be your last state? Are you going to write in this manner like 15, 14, 13, 12, 11, 10, 9, 8, 7, then 6, 5, 4, and at 4 will be my last state. My last state will be 4. But are you going to calculate in this manner? No. Think on your own. No? This is a basic aptitude problem. Let's just say if I was designing mode 2 down counter, then my final state would have been 14. If I am designing mode 2 counter, then my final stage is 14. How I can get 14? 16 minus mode 2 counter, 14. If I was designing mode 3 counter, then my final stage would have been 13. Mode 3. Mode 3. So this you don't need to mug up. In the examination you can think this much thing. Like you can think this much of analysis in the examination only. That mode 3 counter and my final state will be 13 only. If I am designing mode 3 counter starting from 15, then my final stage will be 13 only. So 16 minus 3, 13. If I need to design mode 12 counter, so what will be my final state? What will be the final state? 16 minus 12. So this will be my final state. So my final state will be 4. So this is your aptitude. Like even from wherever you have studied this topic, even your teacher will not tell you this. You need to think on your own. So here I have told you how to think in the examination, right? Like mostly people will write down all the things, but just do the smartly. Just do it smartly. Mode 2, 16 minus 2. Mode 3, 16 minus 3. Mode 12. Mode 12, then 16 minus 12. So this will be my last state. So which state I do not want? Which state I do not want? So Q3, Q2, Q1, Q0. Which state I do not want? And tell me one thing, here you will use preset input or clear input? I need to set my output. I need to set my output. I again need to go to 1111. That means I need to set my output. So I will use preset input, right? So I will use preset input. And which state I do not want? That is 3. And 3 will be 0, 0, 1, 1. In case of down counter, always look at zeros only. In case of down counter, always look at 0. So Q3 plus Q2. You want your pre-input to be high or low? You want your pre-input to be high. So I am looking at 0, Q3 plus Q2. I want it to be high. 0 plus 0 will give me 0. I want it to be high. There you go. You can use 2 input NOR gate. What you can use? You can use 2 input NOR gate. 2 input NOR gate. Q3, Q2. So this is the simplest question that has been asked in gate examination. In gate examination, these kind of questions have come, but this has not been asked yet. Okay. In written test of some companies, I have seen these kind of questions. Okay. Consider all flops to be reset, and what will be your optimized pre or clear input? Clear input. They will say that you will use pre input or clear input, but here we can think on our own as well, whether we are going to use pre or clear. And then they will ask what will be your optimized design. 2 input NOR gate with these inputs, 2 input AND gate with these inputs. So that they will ask. So what you will do there? First you need to think that consider all flops are reset. If all flops are reset, so for second one, just ignore this. All flops are reset. All flops are reset. So you need to go down counter you are designing. So this is how you are going, right? You are not starting from the maximum one. It is not maximum. If you are not starting from maximum one, that means no shortcut is applicable. No shortcut applicable. You have to solve conventionally. Now the second thing is, are you going to make the table? Like, are you going to write down Q3, Q2, Q1 and Q0? and then 0 0 0 0, and then you are you going to make the table in this manner? No, no, no. We are smart. First thing is I will find my final state. So I am going from 0 to I am going to 15, then I am going to 14, and then I will find my final state. If I was designing mode 3 counter, then my final state was 14. How can I get that? 16 minus 3, that will give me 13 plus 1. If I am designing mode 12 counter, what will be my final state? That I don't know. So 16 minus 12, what I am getting? 4 plus 1. That will be my final state. So my final state will be 5. What did I do here? If I was designing mode 3 counter, then my final state would have been 14. 0, 15, 14. Final state would have been 14. So how I can get 14? 16 minus 3, that is give me 13. I need 14. So plus 1 I need to do. If I am designing mode 12 counter, so 16 minus 12, 4, but plus 1 I need to do. So this will be my final state. Now you can count that from 0 to count back to 5, you will get 12 states only. Right? 0, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5. Yeah, last state is 5. So what you don't want? Which one is the first stage that you don't want? You don't want 4. You don't want 4. So if I say only look at, and what you are going to use, clear or preset? Clear, right? I want to use clear input because I need my output to be cleared so that I can come back to 0. So if I say that I want my clear input to be, I will look at 0. In case of down counter, I will look at 0, Q3 plus Q1 plus Q0, and I want my clear input to be high. So I will put a bar there. This is wrong because you cannot apply shortcut method here. So this is wrong. Okay, this is wrong. So let's not write it. So one thing I know that this is my 4. So at 4 my clear input should be 1. At 4 my clear input should be 1. Then my 3 will be don't care, 2 will be don't care, and 1 will be don't care. Say yes or no. Here I want it to be 1. So 3 will be don't care, 2 will be don't care, 1 will be don't care. 0 will also be don't care. No, 0 is there in the loop. At 0 you want clear to be 0 only. At 0 you want clear to be 0, right? But luckily here only one loop is possible, no? So this was not a good example to take actually, because this is only possible here. Like you cannot make any pair as well. So the answer that you wrote here, that would be correct. But luckily you got the correct answer. Let's just say if the don't care was here as well, then there was an issue. In the last example only, when we were studying about mode 5 counter, here mode 5 was there, no? Mode 5 counter. So here we got to know that we are getting different answer. In this case, there was a different answer. Okay. And then like here you were using preset and there was a different answer. And if I use the shortcut method, then I would get the answer wrong. Q2 bar would be wrong here. The actual answer is Q2 bar into Q0. Okay. But from shortcut method, I would have got here Q3 plus Q1 plus Q0 bar. I guess I will get the same thing. Let's check. I don't think I will get the same thing. Let's check. So what I am going to get? 1. Clear is 1. When it is 1? It is 1 at Q3 bar, Q2, Q1 bar and Q0 bar, right? So this is your clear input. This is your clear input. Like what is actually told, that people will say that for clear input you assume POS SOP form. So Q3 bar, Q2, Q1 bar, Q0. But that in that complexity we are not going. What I have told till now, only thing I have told, when you are designing down counter, always look at 0. And it is easy to remember. Down, you are coming down in your life, you need to look at 0. No matter whether you are designing pre-input or clear input, if you are counting down, always look at 0. Okay. But make sure that for that trick, you should start from the maximum value. You should start from 1, 1, 1, 1. If you are starting from any other value, that trick will not be applicable and you need to do the analysis on your own in this manner. Okay. So that is the only thing you need to remember. What is the conclusion till now? I am telling it again. What is the conclusion till now? You are designing down counter. Till now we have studied down counter only, but we are studying mode n down counter. It is not mode 2 to the power n, any mode particular number. So in that case, if you are starting right from the maximum and you need to design your pre-input. If you are starting from the maximum, then certainly you need to design your pre-input only. If you are starting right from the maximum and you are going down, then first you will see which state I do not want. You know the state that you don't want, then you will write down the values there, q3, q2, q1, q0. So 0, 1, 0, 0 I don't want. If you are starting right from the maximum, then there is a trick that you will always look at 0 only. In case of down counter, I will always look at 0. So I will highlight that line. In case of down counter, always look at 0. Where I wrote that line? Somewhere it would be, you can highlight that line. Okay, you can highlight that particular line. For down counter, always look at zeros. So this is the important line, that you will always look at 0 for down counter. Okay, you do not need to remember for pre input I will look at 0, or for clear input I will look at 0. For down counter you will always look at 0. Okay, now in this case the trick was applicable because you are starting right from the maximum. If I am starting right from the maximum, I will just look at zeros. So q2 and q0. So q2 plus q0. If I am looking at 0, I will write VOS form q2 plus q0. And then I want my pre input to be 1, so I will take a bar. If I wanted my pre bar input to be 0, so I would not take a bar. There you go. So this is how I will be solving it. Okay. So this is the optimized design. So this is the optimized design, which is my clear input should be this. Okay. And usually what is said is that in down counter you will always use preset input. In down counter you will always use preset input. This is said, but this is absolutely wrong, right? It is not necessary that I need to use preset input always. I can use other inputs as well. Say yes or no? In down counter, it's not necessary that I will use preset input. Here I am designing down counter only, and I am using reset input. Sorry, I am using clear, right? I am using clear input here. So it's not necessary that you always need to use preset input only. So all these like misconceptions are there that we are clearing, right? So I hope your misconceptions are clear now, that you can use pre or clear both simultaneously in your design. You just need to know whether you want your states to be go to reset or you want your states to be set. So in this case, I want my states to be reset. I want my old states to be clear. So that's why I used clear here. And in the previous case, I wanted my old states to be set. That's why I use pre input here or preset input here. Okay. And if I was starting from maximum, then my shortcut is applicable. If I am starting from any other value, then shortcut is not applicable. I have to make the K map. Till now, everything is clear, right? Now we are going to do the same thing in up counter, but before that, let's see some questions. So these kind of questions are asked in the examination. Okay. So input of black box is given. This black box can have the input in the function of q0, q1, q2, q3. I don't know what I am going to use. I might use only q0. I might use only q2. I might use two of that. So they are saying that input of black box could be a function of q0, q1, q2, q3. For mode 10 ripple counter, you need to find the optimized black box. So here they did not give down counter or up counter. They also did not tell whether you are starting from maximum or some other value. Okay. So let's solve it. They do not need to tell whether it is down counter or up counter. You can see from the design as well. This is a simple design that we have already studied. All are in toggle mode. All in toggle. All are in toggle mode. All are in toggle mode. Plus, what is the second thing? Output of float is given as clock to other float. So if two things are there, then that means certainly it is a asynchronous counter. Now it is up or down? Plus, down counter. So it is a down counter, that I got to know. Now what I am using here, this could be pre-bar, this should be written as pre-bar, okay, reset bar, because these are bubbles there, no? So they will be writing as preset bar. So tell me one thing, what I am using here? Preset input. Preset is used. And what preset will do? It will take output to 1111. It will take your output to 1111. So in the loop, what is your target? To go to the output 1111. Here what was my target in this case? To go to 0000. That's why I used clear input. Here what was my target? To go to 1111. What I was using? Preset. So if I am using preset, by default I can take that I am starting from 1111 only, no? Are you getting this point? If I am using preset, that means I must have started from 1111, right? Then I will go to 1110. In that manner I will be proceeding. So what will be my loop? What I need to design? Mode 10 counter, mode 10. So we will be starting from maximum, that is, what is the maximum one? Maximum is 15. So 15, 14. In that manner you will go. Will you count it up? That what will be my final state? No, I will think of it. Firstly, what I am designing? Down counter. I am designing down counter. What I am designing? Down counter. So in down counter, what I am expected to do? I should start from the maximum. If I am designing down counter, that means I am expected to start from the maximum. Start from maximum. And where I am starting from? I am actually starting from maximum as well. I am starting from maximum only. That means trick is applicable. So here the trick is applicable. Are you getting this point? So this is how I am going to think in the examination. I am not mugging up anything. Did I mug up here anything? No. I am using preset bar. That means it is I like preset bar or preset. Basically, I am using preset input. Whenever it is active, I will go to 1111 stage. If I am going to 1111 state, that means I am starting from here only. So 15, 14, and then in the loop I am going. This loop I am going. This is a mode 10 down counter. If it is a down counter, then where I am expected to start from? If it is a down counter, then I am expected that I should start from the maximum one. And actually I am starting from the maximum one only. So there this trick will be applicable. Right? I am expected to start from the maximum and I am actually starting from the maximum only. So that trick will be applicable here now. Right? So that trick is applicable now. So what is that trick? That what is your final state? What is your final state? So first that you need to find what is your final state. So if I was designing mode 2 counter, what was my final state? 14. So 16 minus 2, 14. If you are designing mode 2 counter, your final state was 14. Two states were there. If you want to design mode 10 counter, what will be your final state? So 16 minus 10, that would be 6. If I was designing mode 2 counter, my final state was 14. If I am designing mode 10 counter, my final state will be 6. So this will be my final state. So which one is the first unused? This analysis I am not writing up now. Okay, which one is the first unused state? Q3, Q2, Q1, Q0. Which one is first unused state? That is 5. And how you can write 5? 1, 0, 0, 1. Right? This is your 5. Here trick is applicable. For pre-input, what is your input? Pre-bar actually. Your input is pre-bar. You will look only at 0. If I am looking at 0, I am thinking of POS. So Q3 plus Q1. So Q3 plus Q1, 0 plus 0 will give me 0 only. 0 plus 0 will give me 0 only. And I need pre-bar to be 0 only. So yeah, that's correct. Okay then. So this is the answer. Okay. So this question is solved. Now you solve the next question on your own. I will pause the video. I have some task to do. Okay. So solve it on your own. Then I will come back. Yeah. So in this example, what will be your black box? What will be your black box? Your black box will simply be a XOR. Not sorry XOR. It will be simply a OR gate. Q3 plus Q1. It will be a OR gate. Right? Q3 plus Q1. Okay. And more possibilities are there. What are the more possibilities? Look, how they can frame the option. This is your final answer. There is no doubt about that. But what if I do this thing? I introduce two inverters here. Okay. And this is my pre-bar. This is my pre-bar. No issue about that. Two inputs are introduced. This was your Q3. This was your Q1. What is this? What is this structure? This is an AND gate. This is an AND gate, right? So this is your Q3 and then there is a NAND gate. Pre-bar, right? And this was your Q3. This was your Q1. Or what I can write? To the NAND gate, what is being fed? Q3 bar and Q1 bar. And then there is an AND gate. So they can frame the option one option. The black box is OR gate with input Q3 and Q1, correct. The black box is NAND gate with input Q3 bar and Q1 bar. Yes, that is also correct. Are you getting this point? So always at the input try introducing two bubbles. Why they will do so? Because in the flow you will, if you are having Q3, then certainly you are having Q3 bar as well. So you can take this Q3 bar and feed to the input as well. Feed to this black box. Right? So they can frame the option in this manner. That if your input is Q3, if your input is Q3, then Q3 and Q1, then you are using OR gate. If my inputs are Q3 bar and Q1 bar, then I am using NAND gate. So two way these options can be framed. Let's move to the next question now. This question we need to solve, right? So this question you need to solve. What input you are using? What is this first? Down counter. Down ripple counter. Same circuit is there. There is no doubt about that. And black box could be function of this. Mode 10 ripple counter is there. Optimize the black box. So clear input you are using. Clear input. So what do you think where you must be starting from? If clear is there, what is the job of clear? To take all the outputs to 0. So eventually you want to come here, and now you need to down count. Now you need to down count. Now you need to down count. And in this manner I will go. Okay. So how I am down counting? From 0 to 15 to 14, and in this manner this will be my last state that I don't know, and then I am using clear input so that I would go to 0. Okay. And it is clear or clear bar? It is clear bar actually, right? Clear bar. This is your clear bar. So is the trick applicable here? Is the trick applicable? No. So this clear bar I want it to be 0, right? I want clear bar to be 0. For rest of them I want it to be 1, and then clear bar is there, so I want it to be 0 when the state that comes that I don't want. So which state I don't want? So if I was designing mode 2 counter, my final state would have been 15. How I would got it? 16 minus 2, that would give me 14 plus 1. If I am designing mode 10 counter, so what will be my final state? 16 minus mode 10, 10, and then 6 plus 1. So this will be my final state. My final state would be 7. So always take an example of mode 2. Final state is 15. 16 minus 2 you will do 14. You will get 14 plus 1. So similarly this will be 16. So what is the first state that I don't want? State that I don't want. That will be 6. So the state that I don't want, that will be 6. And there my clear input should be 0 or 1. Clear bar input should be 0. And the states below I do not want now. 6, then 5 will be don't care. Do not want means these states will not even come. 0, 15, 14, 13, 12, 11, 10, all these states will come till 7. Then at 6 I want my clear to be 0, so that my outputs are reset. Reset means goes to 0. So I want my clear input to be active, and here activation means applying 0. And 5 should be don't care, 4 should be don't care, 1 should be don't care, 2 should be don't care, 3 should be don't care, 0 should be don't care. 0 should be don't care or not? No, 0 should not be don't care, because at 0 you want your clear bar to be 1. Right? So here it is 1, so it is not don't care. So what all are the possible outputs? I can see there are two possible outputs. One is this, and other one is, I will use the different color. I can use this color, this. So two possible outputs are there. So now what will be my clear input? And take care that what you are using, 0 0 0 0 you are using, that means I need to write POS form. So if I write here in this loop, so what is constant in this pair? That Q1 bar is constant plus Q naught is constant in this pair. Q1 bar plus Q naught plus this 0 is also constant plus Q3, or in this pair if you see, so Q3 plus Q2 bar plus Q3 plus Q2 bar, and what else is constant? This 0 is constant, so plus Q naught. Q3 plus Q2 bar plus Q naught. Q3 plus Q2 bar plus Q naught. Yeah. So these two possible outputs are there for clear input, clear bar input, right? These are the outputs of clear bar input. Here we are simply making the, what we are making? Here we are simply making the K map. So conventionally we are solving it. We are not applying any trick. If I had applied the trick, so which I don't want the state 6. So that would be 1 1 0 0. If I had applied the trick, so I need to take clear bar. So in case of down counter, you always look at 0. So I would write Q3 plus Q1, and I wanted to 0 only. So this would be my answer, Q3 plus Q1. That would be wrong, right? Q3 plus Q1 would be wrong. Why is that wrong? Because we are not starting here from the maximum. In case of down counter, I am expected to start from the maximum. In case of down counter, I am expected to start from the maximum. If I am not starting from the maximum, then the trick is not applicable. Not maximum, then trick not applicable. So this thing you need to take care. I am highly hopeful that these kind of questions will come in your GATE examination from any year onwards. Okay, if they start coming, then they can come any year. Usually what they ask is that they will start from 15, okay, and then they will ask the preset input here, but we are starting from a random value and then we are asking this. So Q3 plus Q2 bar plus Q naught. Now how you can represent that? So I am representing this one, first one. So Q1 bar, look, I do not need to use an inverter here. I will directly write that Q1 bar, Q naught and Q3. Why is that so? Because from my flip-flop I can get Q1 bar, no? Because in my flip-flop only I will have Q1 and Q1 bar both. So there I am not using any inverter here, okay? And then Q naught is there, and then Q naught is there, Q3 is there, and this will be my clear bar output. Is there any other possible design? You will say that, sir, this is possible. Yeah, this is possible, but any other possible design is there? Say yes or no. Yes, it is possible. What is that? Use inverter here, inverter here, inverter here, inverter here, inverter here, and inverter here. So what I will get? If I do this thing, what is this equivalent to? This is equivalent to NAND gate. So this will become my NAND gate. This will become my NAND gate. Right? What will happen to these inputs? Tell me, what will happen to these inputs? They will also be complemented, no? Because double bar you will be using. So these will be complemented. So if you are using a NAND gate, then you will put Q1 here, Q naught bar and Q3 bar. So how they can frame the option? That I will use 3 input OR gate with inputs being Q1 bar, Q naught, Q3. Second option, I will use 3 input NAND gate with the inputs being Q1, Q naught bar, Q3 bar. Or I will use 3 inputs OR gate, 3 input OR gate with inputs being Q3, Q2 bar and Q naught. Q3, Q2 bar and Q naught. This is also correct. Or I will be using 3 input NAND gate with inputs being Q3 bar, Q2 and Q naught. All options are correct. Say yes or no. Right? So all 4 options are correct. So these kind of questions can come in MSQ. So very good chance that they can frame these kind of questions. Okay. And what we are actually doing to make it NAND gate? What do you think? We are just taking the double bar. Look, this is your clear bar. No? So in the examination, if you are not going to follow this method, then what you can do? To get the other answer, what you can do? Just take the double bar. If I am taking the double bar, what I am getting? Q1 dot Q naught bar dot Q3 bar bar. So you can see Q1, Q naught bar, Q3 bar, and then multiplication and then bar. So NAND gate of Q1, Q naught bar and Q3 bar. I think this is crystal clear. I am telling all possible scenarios that can come in your examination. All possible scenarios and all possible method from where you can approach. Whatever the method you like, whatever the method that you are comfortable with, from there you can proceed. So just solve this problem on your own again. If you have solved it already, then it is pretty good. If you haven't solved, then you can solve it again and then see if you are able to catch all the data or not. Like if I could have taught this topic very in like 10 to 15 minutes, because it is taught in 10 to 15 minutes only, but there is a lot of depth that should be covered in this particular topic, which is not usually taught. So that's why we are going deeper into it. So whatever the possible scenarios we can come, because there is a problem that they can ask in MSQ, and certainly in placements questions, like there will be high chance that they will ask your counter from any random value. From any random value they can start. Okay, they can start from 13 as well. From 13 you are designing the down counter. So what will be your preset input or clear input? So if you apply any trick work there, that will not work. And what is the trick? If we are starting from the maximum, so there only trick will be applicable. And what is the trick? It is very simple. In case of down counter, look only at 0. So I will look at 0. I will see whether I want my preset input to be high or low. So if I want it high, then I will take the bar. If I want it low, then I will not do anything. That will be my final answer. There you go. Okay. So find the mode of the given counter. You need to find the mode of the given counter. Okay. So first thing, is it a down counter or up counter? Down counter. All flip-flops are in toggle mode. First you need to see this thing, that all are toggle mode and it is a down counter. Okay, it is a down counter. Preset input is there. This preset input is there, which is Q2 bar and Q1. Okay, then certainly, and you don't know whether it is starting from active high or active low. Whether it is starting from 1111 or 000 or some random value. What do you think where it is starting from? If preset is there, then certainly it would be starting from the maximum, right? If preset is there, what is the job of preset? To take all the outputs to set. Then certainly it would be starting from 1111, right? Then to 110, then to 101, then in that manner it should be going. So certainly you are starting from the maximum. Okay, and what is the pre-input? Q2 bar Q1. So he wants Q2 to be 0 and Q1 to be 1, and where Q0 is don't care. Q0 is don't care. This is what he wants. Now tell me one thing, whether you will take the Q0 from this expression, from this 0 1 don't care, you can tell no where the loop will break. Like you are starting from 7, you will go to 6, you will go to 5, and somewhere loop will break, right? Somewhere loop will break. So this will be that value where the loop is broken. Where the loop is broken. So this is that value, that is 0 1 don't care. So tell me one thing, at the place of don't care you are going to put 1 or 0. Think and tell. At the place of don't care you are going to put 1 or 0. You will put 1 there. Why is that so? Because if I put 1, what I am getting? 3. If I put 2, what I am getting? Sorry, if I put 1, I am getting 3. If I put 0, then I am getting 2. So do you want this to be 2? If you are saying that in my loop my final stage is 3, that means I am going from 7, 6, and my final stage is 3. Then you can never say that my preset input is this. Why you can never say? Because you are saying that 0 1 don't care. Don't care can take any value, and let's just say if it has taken 1 value, that means your loop should be broken here. 3 should not come. So you will take the maximum value, no, not minimum value. Are you getting this point? You will take the 3, not 2, because you are designing down counter. So 7, 6, 5, 4, at 3 only it will be broken. So this stage will be 4 only. So in case of down counter, you don't need to mug it up. Just think. In case of down counter, I am going from 7, 6, 5, 4. Now I need to break the loop. 7, 6, 5, 4. I need to break the loop now. Why is that so? Because I am having my pre-input to be 0, 1, don't care. Now my pre-input can take 3 value as well and 2 value as well. Which value I will pick? The larger one. So this value I will pick, no? The larger one I will pick. Okay? Why I am picking the larger one? Because if I pick the smaller one, then larger one will be there in the loop, and that I don't want. The loop should be broken before 3 only. The loop should be broken before 3. So I will pick the larger one value. So 0, 1, 1, 1. in case of down counter, what you will pick? What do you think? In case of down counter, this is the case of down counter. Sorry, in case of up counter, what you will pick? In up counter, I will be going from 0, 1, 2, and then let's just say this is coming, and then again I have to go to 0. So my loop is broken here, that I don't know, and let's just say I'm calling it as 1, 0, don't care. So what values it can take? 1, 0, 0 or 1, 0, 1. So this would be 4 and this would be 5. So where you would want your loop to be broken? Before 4 only. In case of up counter, you would want your loop to be broken 4 only, because which state will come first? 4 will come first. 0, 1, 2, 3 and then 4 will come. So you are saying that my output is 0, 1, don't care. This my clear input is 0, 1, don't care. Here I will be using clear input. So this input is 1, 0, don't care. This is what you are saying. 1, 0, don't care. This is what you are saying. And you can say that at don't care I can apply 0 as well and 1 as well. So if I apply 0, that means certainly 4 will not be there in my loop. 4 will not be there. So I will be excluding 4. And if 4 is not there, then certainly 5 will also be not there. If 4 is not there, then certainly 5 is also not there, because you are designing up counter. This is the case of up counter that we are going to see in the next lecture. Okay. But this was the case of down counter. So you are going to pick 3 here. So your loop will be broken at 3. So this was a very important question. There you need to think. Digital electronics is just the aptitude. So where your loop should be broken? At 3 it should be broken. So 0, 1, 1. So what is the mode? From 7 to 4 you are going. From 7 to 4 you are going. So what is the mode? Mode 4. Are we having any other question? No. So now we are going to start mode up counter. So all the models which can be asked in your question paper, that has been covered from asynchronous counter. Now we will see mode up counter, mode up asynchronous non-binary counter, mode up asynchronous non-binary counter, and there we are going to use the same concept. It will be very smooth. Here you must have seen some difficulty that sir, trick is there, but that trick is not that straightforward. Then I have to design it. Then I need to think what will be my last state. So it is the complete aptitude, but I hope I have given the complete analysis which I could give, like at my level best. Like this much content is more than enough from with this particular topic. From this particular topic, these models we have covered. So apart from this model, no questions can be asked. Okay. So I hope you must have understood everything, right? So let's meet you in the next video. There we will see up counter. So same analysis we are going to do. You can do the analysis on your own. So on your own only you will be doing the next lecture completely. Okay. In next lecture, everything will be done by yourself. Okay. Okay then. Thank you very much. Hi everyone. So continuing the previous video. So in the previous video we studied about mode down counter, right? Mode and down counter. So the same analysis we are going to do for the up counter now. So this is the question. You need to design a mode 5 up counter considering initial states are reset. Initial states are reset. Reset means all are at 0, 0, 0. And first thing, what is the mode value? Mode 5. Mode 5. That means number of state you need 5. Number of states are 5. So how many flip-flops you will require? At least 3 I require, right? Okay. So initial states are reset. That means 0, 0, 0. Then you will go to 0, 0, 1. Mode up counter it is. Then you will go to 0, 1, 0. Then you will go to 0, 1, 1. And then you will go to 1, 0, 0. So this is your mode up counter, or you can call it in this manner, that 0 to 1 to 2 to 3 and then to 4 and then here. Okay, mode 5 counter it is. So what do you think, which input you will use, clear or preset? Clear, because I need my output to go to 0. So I will use clear input here, right? So I'm gonna use clear input. So here I am going to use clear input. So which bit I don't want? Which bit I don't want? After that what will come? 1, 0, 1. So what I don't want, that is 1, 0, 1. So value of Q3, not Q3, Q2, Q1 and Q0. So what will be my clear input? That would be Q2 into Q1 bar into Q0. This is not the optimized one. This is not the optimized one, but we know that this, if this is there, that means my clear will be high. For these values 0 0 0, for 0 0 1, 0 1 0, 0 1 1 and 1 0 0, for these values it will never be high. You can check. Put 0 in place of q2, all will be 0. So for these 4 you don't need to check. 1 0 0, if you put 1 here and q0 is 0, so it will always be 0. When it will become high? When q2 is there, q1 is not there and q0 is there, right? So firstly it will become high here only, right? But this is not optimized one. We will optimize it, not optimized, and then we will see what is the shortcut. Not optimized. So that here I can put q2, q1 bar and q0. So simply I will take q2 from here, q2 from here. You can make it using AND gate, right? q2 from here, then q1 bar from here and q0 from here. Just connect an AND gate and just feed it there. So I'm not making the AND gate, you can do it on your own, right? Now how to optimize it, because this is not the optimized design. So for 0 0 0 you want your clear to be 0 only, because this is up counter. Here also you want it to be 0, here you also want it to be 0, here also you want it to be 0 only, and here also you want it 0 only. So this will make your mode 5 counter, not this one, till here, till here. This will make your mode 5 up counter, right? So this is your mode 5 up counter. This will make mode 5 up counter. What about these? At 1 0 1 you want your clear to be 1, and 1 1 0 and 1 1 1, these conditions will never even arrive, right? So at 1 0 1, that means at 5 you will have 1 and 6 and 7 are don't here. Very easy, like very straightforward. No need to worry about that. Whatever the analysis that we have done in the previous video, the same kind of analysis we are doing here. So which output you will take? This one, right? This one you will take. So in this, what is your clear input? So my clear input is, what is constant here? 1 1, q0 is constant and q3 is constant. So q0 into q3, okay? And if I needed to do the same analysis for clear bar, then for clear bar also I could have done the analysis. What do you think, what will be the analysis for clear bar? Let's do the analysis for clear bar. So for clear, this is the input. For clear bar, just this I am expecting, right? So let's see if we are getting the same thing or not. Okay, so for clear bar, all these should be 1. Analysis for clear bar input, clear bar input. So all these should be 1, right? And this should be 0 and these are don't care. So 4 5 6 7. So my 5 is 0 and these are don't care. So this group I am getting. So what will be my clear bar? Since I am using max terms here, what I am using? Max terms. So since I am using max terms, then 1 1 is constant, so that would be q0 bar plus here it is q3 bar, which can be written as q0 q3 bar. Okay, so in this case you are getting q0 q3 and here you are getting q0 q3 bar only. So simply if clear bar is there, just the just the complement of that will come, right? So how you can represent it? How you can represent it? q0 q3, q0 q3. So this will be my q0, this will be my q3, q0 q3. This will be my clear input, right? If I needed to make clear bar, that means I will introduce 3 bubbles here. So if I am introducing 3 bubbles here, there will be 1 bubble. q0 q3. This will be my clear bar, right? This will be my clear bar. So if I am introducing 1 bubble here, 1 bubble I have to introduce here. What else I can do? How I can replace this guy? I am taking the other form of this. So tell me if you are understanding or not. q0 bar, q3 bar, and then there is a OR gate, then there is an inverter. Will this work or not? What do you think? Will this work or not? This is your clear. This will work or not? Yeah, this is the same thing only. I introduce two bubble here. If I am introducing two bubble here, that means certainly I have to do bar here as well, right? Say yes or no. And what is this? NOR gate. This is NOR gate only. So I did the bar and replaced this with the NOR gate, right? And what you can do with this guy? What you can do with this guy? You can, if you bring this bubble in front, what will happen? If you bring this bubble in front, then these bubble will come in front and this will be replaced with OR gate. Say yes or no. And if this bubble goes here, so this will become Q0 bar, this will become Q3 bar. So if I remove this and I can write, look, we are moving fast, but because we have spent a lot of time in the last lecture only. So this will be Q3 bar. Are you getting this point? This is coming upward, bar, bar, Q0 bar, Q3 bar. Okay, nothing is different, and this is OR gate only. Same concept, ditto same concept. Or from here also you can come here, or from here also you can come here. Any variable. Basically, this bubble went here, and this will become clear bar. So any option can be mentioned in your examination. Now another way of writing optimized input, so shortcut method. Okay. So at what value of Q2, Q1 and Q0 clear will be active for the first time? Since this is mode 5 counter and you are starting from, not pre, it is clear, sorry. You are starting from 0. So 0, what you will do? 0, 1, 2, 3 and sir 4. This is my mode 5 counter, sir. Sir, if this is my mode 5 counter, so what is the first state that I don't want? That is 5. That means Q3, Q2, Q1. This should be 5. Now, in case of up counter, in case of down counter, you are going down in life, that means you are 0. If you are going down in life, that means you are 0. If you are going up in life, that means you are 1. You are number 1. So you will look at number 1. Okay. In case of down counter, always look at 1. And if I am looking at 1, that means I am looking for SOP form, right? So for clear, what will be your clear? Q3 into Q1. If I am looking at 1, that means I am looking for SOP form. So SOP form means product will be there. So Q3 into Q1. This is your clear. And is that your clear? Yeah. Is it my clear? Why so? Will I put a bar here? No, I will not put a bar because Q3 into Q1, 1 into 1 will be 1 and I want my clear to be high. At this point, I want my clear to be high. So Q3 into Q1 is 1 into 1, 1 only. So I will not put a bar. What about clear bar? So again, I will look at 1 only. In case of up counter, I will always look at 1 only. So what is 1? Where I am getting 1? Q3 and Q1. And I am interested in SOP form. If I am interested in SOP form, so Q3 into Q1 I will do. So 1 into 1, 1 it is giving me. But what do I need? I need my output to be 0. I need my clear bar input to be 0. If I need clear bar input to be 0, so I will put a bar here. So 1 into 1 is 1, but bar is there, so it would be 0. Say yes or no, right? Okay then, so this is the shortcut method. You are getting the same thing here. You can check. अरे यार ये फिर गड़बड़ कर दिया मैंने. Like this is the blunder that I make. Q2, Q1 and Q0. These are Q2, Q1, Q0. So Q2 into Q0. Q2 into Q0. Q2 into Q0. This is the blunder that I am again and again making. So this will be Q2, not Q3. Q3 is not even there. Q2, Q2. This is also Q2, this is also Q2. Q2 and Q2, right? Here also again the same thing. This is Q2, 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 Q2. This is also Q2. Okay. Yeah, here it is fine. So that was the scene that this should be Q2, not Q3. I hope you must have understood it. This should be Q2 only. And from here, if I designed it, so all these will be Q2 only. This will also be Q2. And here also I got to know that I should write it more clear. Q2, Q1, Q0. Q2, Q1, Q0. 101. So I will only look at 1. So this and this I will look at Q2 into Q0 because I am interested in SOP form. Q2 into Q0 and then just simply the bar for clear bar because I want my output to be 0. Well and good. Very easy, very smooth. This method will, when it will work? When in case of up counter, in case of up counter, what is expected? That you go all the way down from 0 to high. You are expected in up counter. You are counting up. So you are expected that you will go from least value to the maximum. So certainly it will work for 0, 0, 0 only. If it is starting from minimum value which is 0, 0, 0 only. If it is starting from any other value except this, then it will not work. Let's check. You need to design the same counter, but considering initial flops are set. Initial flops are set. That means you are starting from 1, 1, 1, 1. Then where you will go? This is my 7. If I go from 7 to 6, that means I am counting down. So I need to go to 0. Look, whenever you get confused at the boundary, you will always get confused at the boundary that whether I am going up or down. So always think, if I go from 0 to 1, that means I am going up. If I go from 0 to 7, that will be going down. If I am going from 7 to 6, that means I am going down. If I go from 7 to 0, that means going up. So always at the boundary you check both of the condition, that wherever I can go. 7 to 6 going down, 7 to 1 going up. So yeah, 7 to 1 I will go. Then from 1 to 2 I will go. Sorry, 7 to 0, 0 to 1, 1 to 2, and mode 5 I need to design. So 3. Which input you will use? What do you think? Preset. Why preset? Because you need your initial condition to be set only. So I will use preset input, right? So which is the first one which I don't want? Which is the first state which I don't want? That is 4, 1, 0, 0. Q2, Q1 and Q0. In this one there is no shortcut method. No shortcut method. Because this is not the minimum. This is not minimum. You are expected from 0, 0, 0, but you are starting from 1, 1, 1, 1. So no shortcut method is applicable. You need to do the complete analysis. Yeah, so if shortcut method is not applicable, then what we need to do? We need to design it completely. Okay. So how we will design it completely? So preset input is used, and preset input should be 0 here, 0 here, 0 here, 0 here and 0 here. Till mode 5 counter it should be 0. So you are starting from 7, 0, 1, 2, 3. Till here it should be 0. Mode 5. Till here it should be 0. After that at 1, 0, 0 it should be 1. And these will be don't care. Why I am writing 1, 1, 1 here? 1, 1, 1 is not don't care, right? 1, 1, 1 is here. 1, 1, 1 is not don't care. These are don't care. 1, 1, 1 is not don't care. 1, 1, 1 is there. Okay. At 1, 1, 1 your preset should not be active. 1, 1, 1 is there in the loop. So at 1, 1, 1 preset is not active. So what I will write? This is 4, 5 is don't care and 6 is don't care, right? So there are two possible outputs. Yeah, one color I can use this, another color I can use white one only. Two possible outputs are there. These are the two possible ones. So this is 0, this is 1, 0, 0, 0, 1, 1, 1, 1, 0. Right? So what is my pre-input? Preset or pre, whatever you call it. So two possibilities are there. Let's see the first one. So here Q2 is constant, and what else is constant? Q1 bar is constant. Q1 bar, or Q2 is constant and in this one here Q1 bar were constant. So this we are looking. So here Q0 bar is constant. So these two possible outputs are there. This one and this one, right? Q2 Q1 bar. If I take this loop, so Q2 is constant and Q1 bar is constant, and if I take this loop, then Q2 dot Q0 bar, right? Q0 bar 0, 0. Yeah. So Q2 dot Q0 bar. So these possible outputs are there for preset. For pre. Okay. So for pre bar, what would be the condition? You can just take the bar of that. It would come out to be Q2 bar plus Q1 or Q2 bar plus Q0. You can make the table on your own. Do it on your own. You will be certainly able to tell whether it would be this guy or like you will be certainly able to take out these expression. You can do it on your own. You can make the table. Same loop will be there and just complement plus Q1, right? Solve this question on your own only. So in the first question, consider all flops to be reset. If all are reset, first thing is mode 12. Mode 12. Mode 12. How many states are required? At least 4 states you will require, right? Because with 3 you can get 8 only. With 4 you can get 16. So at least 4 states you will be requiring. So mode 12 and initial all are reset, and you need to count up. You need to count up. So what do you think till what point you will go? This is very easy. You are starting from 0 and 12 states should be there. Starting from 0, 12 states will be there. So you will go till 11, right? This is very easy, no? You are starting from 0 and 12 total states will be there. These numbers should be total 12. So 0, 1, 2, 3 till 11 you will go. 0, 1, 2. How many numbers are there? 3. So 3 states are there, so you are reaching at 2. If 12 states are there, then that means you will reach at 11. Right? In this manner also you can see. So what input you will be using, clear or preset? Clear, right? So I will be using clear here. Okay. So here I will be using clear, and can I apply the shortcut method? Because yes, I can apply, because you are starting from minimum. So shortcut applicable. Okay. So Q3, Q2, Q1 and Q0. Which is the first state that I don't want? Which is the first state? That is 12. From 0 to 11 I have gone, 12 I don't want. In case of up counter, where I will look? In case of up counter, I will always look at the clear input. I will always look at 1 only. I will always look at 1, and if I am looking at 1, I need SOP form. For SOP form, it would be Q3 into Q2. That's it. This is my optimized. So here you do not need to make any table. And what about clear bar? Clear bar will simply the bar of that. So if you take the bar, you will get Q3 bar plus Q2 bar. Okay, well and good. Very easy. Just we have already studied. That's why we are moving fastly in this one. Consider all the initial flops to be set. So in the next one, initial all flops are set. So no shortcut will be applicable. But tell me, what will be your last state? What will be your last state? For mode 12 counter. Mode 12 counter. You are starting from 15, 0, 1. So for mode 3 counter, last state is 1. 15, 0, 1, 2. For mode 4 counter, last state is 2. So for mode 12 counter, what will be the last state? 10. Mode 12 counter you require, so last state will be 10, right? In that manner also you can see, or you can see that these two are eating up 2 states. So 10 states will be remaining, so this will be 10 only. Anyway, you can see this is very easy. Like if you are coming down, then it would be tough. Like this is the simple calculation, no? Like simple counting. You are just counting 15, 0, 1, 2. So till 12 state, what will be the condition? 10. Very easily we can see. So very easily we can see. So all these we want in loop. So which states we do not want? Starting from 11. Starting from 11. Starting from 11 I do not want. Starting from 11. So where is 11? This is 11. Right? And which input I am using? Preset. Did I tell you here? No. So which input I will use here? Preset. Why preset? Because I need to set my output. I need to set my output. Eventually I need to set my output. So I will be using preset. Starting from 11. Starting from 11. So this is my 11. And which all will be don't care? 12, 13 and 14. 12, 13 and 15 will be don't care? No, 15 should be 0. Because at this input you do not want your preset to be high. So now you are not getting any other quad here. So only one. No, you are not even getting quad. You are not even getting pair. So only single element will come. And this single element is, so what is your preset? This single element is Q3 into Q2 bar into Q1 into Q0. So this will be your preset. Well and good. Very easy problem. Okay. Let's go to the next one. Black box design you need to do. They are using clear bar input. What do you think? Where it will start from? If they are using clear, that means it will start from 0, 0 only, and mode 10 counter is there. Mode 10 counter is there. 4 flops are there. So it will be starting from 0, 0, 0. Why 0, 0, 0? Because they are using clear input. If they are using clear input, that means they want their output to be clear. They want these outputs to be clear. So it will be starting from 0, 0, 0 only. This we have already seen. Then what you will get? 1. What will be the last state? Mode 10 counter it is. From 0, 1, you need 10 states. So what will be the last state? 9. Right? Because you are starting from 0. So last state will be 9. And then you are using your clear input. Okay. So which is the first state that I don't want? First state that I don't want. That is 10 only. First state that I don't want, that is 10. So what will be 10? Q3, Q2, Q1, Q0. What will be 10? 1, 0, 1, 0. Right? So let's write it on the next page. Okay, first question I am writing, that is the first state that I don't want, that is 10 only. 1 0 1 0. And what I am doing, up counter. In case of up counter, I will always look at ones only. So which input I am writing? Clear input I am writing. No, I need clear bar input. Clear bar. I need clear bar. Okay. If I need clear bar, so I will always look at ones only. In case of up counter, I will always look at ones only. So what all are the ones? And if I am looking at ones, that means I want SOP form. So Q3 into Q1. So Q3 into Q1, 1 into 1 will give you 1 only, but I need 0. To activate this clear bar, I need 0. So that would be my output. Q3 into Q1 bar. Okay. Or you can write it as Q3 bar plus Q1 bar. So what all gates you can use? Q3, Q1. This gate you can use, right? Then you can give your clear bar there. Or what else you can use? Simply OR gate. Q3 bar and Q1 bar. Simply OR gate it is. Q3 bar plus Q1 bar. This is also clear, right? So very easily you have written down. Let's see the second one. Okay, no, next question will be there. So this is your black box. Your black box could be AND gate, NAND gate as well. It would be OR gate as well, right? Two possible conditions are there: NAND gate or OR gate. Okay, let's see this condition. They are using preset input. What do you mean by that? If they are using preset input, that means they want their state to be preset first. So you will be starting from 15, then you are going towards 0, okay, and then 1. What do you think? What will be your last state for mode 10 counter? Starting from 15, 15, 0 and 1. This is mode 3 counter. Mode 4 counter will be 15, 0, 1, 2. This will be your mode 4 counter. What you need? Mode 10 counter. So here 2 states less, here also 2 states less. In mode 10 counter, 2 states less. It would be 8. So final state will be 8. So final state will be 8. Final state will be 8. Right? And this will be fed back. And which input you will use? Preset input. In case of up counter, you are expected to go from all the way down to up, right? Down to up. That means you are expected to go from 0, 0, 0 to up. But you are starting from 1, 1, 1, 1. That means shortcut not applicable. This is not the minimum value. Shortcut not applicable. So till 8 you are there in the loop. Till 8 you are there in the loop. So from 9 onwards you will start having 1. So here you will have 1, right? At 10 you will have 1 or not? No, sorry, not 1. Here you need your preset bar. Here you need preset bar to be 0, right? To activate. To activate you need it to be 0. For rest of the cases you want it 1 to activate. So at 9 I want it to activate. So at 9 I want it to activate. And 10 don't care. 11 don't care. 12 don't care. 13 don't care. 14 don't care. 15 don't care. No. At 15 you are having this state. So at 15 you want your preset bar to be 1. So that will not come. So what do you think which I'm gonna select? So again 2 possibilities are there. This possibility is there and this possibility is there. 2 possibilities are there. So let's write down what will be my pre-bar input. So that could be, in this case, what is constant? Q3 bar plus Q2. I am writing zeros. Zeros means I am interested in zeros. Here I am writing 0. 0 means POS form. So I will be writing POS form here. Q3 bar plus Q2 and then 1 1 is constant. So Q0 bar. Q3 bar plus Q2 and 1 1 is constant. So Q0 bar. And or what could be the other answer? This could be the other answer. What is that? Here 1 is constant. So Q3 bar plus, in this one both are constant only. So Q1 plus Q0 bar. Well and good. Everything is crystal clear. Just I am writing the output. Again let me check. Q1 plus Q0 bar and Q3. And what about this? here it is 1. So Q naught bar, and here Q3 bar plus Q2, Q3 bar plus Q2. So these two are the possible designs, right? More possible answer could be there. So these are the possible ones which I can directly see with the NOR gate. So this could be your black box, not NOR gate, sorry, with OR gate. This could be your black box. This could also be your black box with these inputs. These inputs are Q3 bar, Q2 and Q naught bar, and Q3 bar, Q1 and Q naught bar, right? And what else is possible? If I want to make it an AND gate, if I want to make it an AND gate, then how I will make it an AND gate? You use bubble here, bubble here, bubble here, and then bubble can go out, upward. So what would be the answer? Bubble, bubble, bubble. If I use bubble here, this will become Q3. This will be my NAND gate. This will become Q3. This will become Q2 bar, and this will become Q naught. So this is the third possibility. What will be the fourth one? Same for this. What I am doing, I am introducing a bubble here. So if I introduce a bubble here, certainly here also I will need to introduce a bubble. So if this bubble is fed to this guy, this will be Q3. This bubble is fed to this will be Q bar, and this bubble is fed to this will be Q naught, right? So let's remove these bubbles, and this is how I can make my next design. That would be bubble goes here, Q3, bubble goes here. ये फिर मैंने Q3 गड़बड़ कर लिया, नहीं की. So Q3, Q1 and Q naught. I am having Elaichi again. Okay, nothing else. I am not the fan of Akshay Kumar or Ajay Devgan. So Elaichi I am having so that I could record in a better manner without even coughing. So yeah, Q3, Q1 bar, Q naught. Okay. Like Elaichi helps if you put it in your mouth and then you speak something, then there is very rare chance that cough would come. So that's why I record my videos having the Elaichi. Okay. Let's see this question. That same kind of conceptual question. You need to find the mode. Okay. So find the mode. So what kind of counter is that? First thing you will see that all are in toggle mode. All are in toggle mode. Okay. Secondly, output of one float, clock of other float, right? So what do you get by that? This is asynchronous, or you can say it is ripple. If it is asynchronous, then what do you see here? Up counter or down counter? So plus minus up counter. This is your up counter. Okay, in all these examples as well, you need to check if it up counter or down counter. I forgot to tell. Plus minus up counter. Okay, in the previous example as well, plus minus up counter only. So first you need to check whether it is up counter or down counter. So you check that it is a asynchronous up counter. And just as you notice clear, that means it is what? If there is clear available, that means certainly it is non-binary. So where it will stop? And if you are using clear, so where you are starting from? If you are using clear, then certainly you are starting from 0, 0, 0. 3 states are there, so you are certainly starting from 0, 0, 0. Because if you are using clear, then certainly this is your task that you want your all output to go to 0. So you are starting from 0, 0, 0, then you are going to 1, and in that manner you are proceeding. So where you will stop? So that will be told by this clear input. So that is Q2 bar, Q1. That means 0, 1, and what about Q naught? Q naught is don't care. So what all possible values you can have? 0, 1, 0 and 0, 1, 1. So this is your 2, this is your 3. So where will you stop? What do you think? You are going from 0, 1. What you will encounter first? 2 you will encounter first. You are going up. So 2 you will encounter first. So you are going to encounter 2 first, right? Not 3. So 2 also cannot be there in your loop. Clear is saying that 2 cannot be there in your loop. So if 2 cannot be there, then certainly 3 can also not be there, no? Are you getting this point? In case of down counter, what we were doing? We were taking the maximum value. That there was also this scene only, no? 1, 0, 0, 0, 1, 0 and 0, 1, 1. So you said 2 is also possible, 3 is also possible. So which value I took? 3. Why is that so? Because you were starting from the upper side there. You were starting 7, 6, 5, 4. First 3 will come. And if 3 is there in the loop, then this output cannot be possible. That means certainly 3 is not there in the loop. So it will be cancelling at 3 only, direct at 3 only it will be cancelling. So till number 4 will be there in the loop. And in this case, you are starting from bottom, 0, 1, 2 number cannot be there because at 2 only it is certainly cancelling. So 2 number can also not be there. So only this loop will be there. There you go, this loop. Okay. So in case of up counter, you will always take the minimum value. In case of down counter, you will always take the maximum value. Don't mug it up. Think in the examination. This is not something that you should mug up. At least this much aptitude we should have, that we can think in the examination that we are starting from 0. Okay, if just as the minimum number comes, there I will break my loop. So here I am breaking my loop. So what is the mode number? Mode 2. There you go. Okay, very simple. Now, so your up counter, down counter has finished. Let's see something very interesting. Okay, something we will, what do we say? We will observe here. So this was the table of our down counter only. Now, if I am starting from set, so 1, 1, 1, then this is my 7, then 6, then 5, then 4, then 3. This is what mode 5. So mode 5 is done here. Mode 5 is done here. Right? After that, this sequence only will be repeated. 7, 6, 5, 4, 3. What do you think? What is the frequency of this bit? If clock frequency is F clock, each sequence, what it represents? T clock. Each sequence represents T clock. So every sequence is T clock, right? So here 1, 1, 0, 1, 0, 1, and then again 1. Did you notice this? Did you notice this thing? So here 1, 0, 1, 0. It is not F clock by 2. 1, 0, 1, 0, 1, 1, 0, 1, 0, 1. Then again 1, 0, 1, 0, 1. So this is your complete cycle. Are you getting this point? Okay. So for Q naught, what is the frequency? F clock by, tell me, F clock by 5. Why F clock by 5? 1 cycle, 2 cycle, 3 cycle, 4 cycle, 5 cycle. So for Q naught, the frequency is F clock by 5. What about Q1? See it on your own. Okay. Try seeing it on your own. What do you think? What is being repeated? Look, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1. So always when the question is coming on mode 5 counter, you should not, sorry, if question is coming from asynchronous non-binary counter, these are non-binary counter. In case of binary counter, we have studied F clock by 2, F clock by 4, F clock by 8, and finally we will have F clock by 2 to the power n. But if non-binary counter is there, like your loop is being broken in between, so there you should write down the output, at least write till 2 repetition. Here I have written 7, 6, 5, 7, 6, 5, 4, 3, then 7, 6, 5, 4, 3. So you will be able to visualize, okay, F clock by 5. For Q1 as well, you are able to visualize 0, 0, 1, 1, sorry, 1, 1, 0, 0, and then 1. Now the same cycle will be repeated. 1, 1, 0, and then 1. So 1, 1, 0, 1, 1, 1, 0, 1. So here also it is F clock by 5. For Q2, what is the scene? 4 times 1, 1 times 0. 4 times 1, 1 times 0. So each is representing 1 T clock, T clock, T clock, T clock, T clock, T clock. 5 T clock is there. That means the time period is 5 T clock. So what will be the frequency? F clock by 5. So shall we make an assumption that always it will be F clock by mode number? Huh? It should be always F clock by mode number. No. Let's take another example. Mode 6 down counter I am taking. Mode 6 down counter. So what do you observe here? 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So what is the frequency for Q naught? F clock by 2. Here you are getting F clock by mode number. All these were F clock by mode number. But here you are directly getting F clock by 2. So that formula is gone. F clock by mode number is wrong. For Q1, what you are getting? 1, 1, 0, 1, 1, 1, 1, 0, 1, 1. What you can see? 1, 1, 0, 1, 1. So in this one there are 6, right? So F clock by 6. T clock plus 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 T clock. Then same cycle is being repeated 1, 1, 0, 1, 1. So F clock by 6. What about Q2? 4 times 1, 2 times 0, then 4 times 1, 2 times 0. So this is also f clock by 6. So here your rule went wrong. Are you getting this point? Let's see this one in mode 4 down counter, initially reset. So what do you see? 0, 1, 0, 1, 0, 1. What you are having? For Q0, f clock by 2. For Q1, what you are having? You can check. 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. So these 4 cycles, 0, 1, 1, 0, and then it is being repeated. So f clock by 4. And for Q2, again it would be f clock by 4. So 0, 1, 1, and then again 0. And after that it will be repeated. So 1, 2, 3, 4, f clock by 4. Okay. So it is being changed. This can also change actually, but this will never change. Okay. This will always be f clock by mode number. We can see the same thing in up counter as well. So for Q0, what will be the frequency? You can see 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 1. So it is f clock by 2. For Q1, what it is? 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 0, 0, then 0, 0, 1, 1, 0, f clock by 6. And for Q2 as well, it is f clock by 6. Luckily, in all the cases, we are getting this as f clock by mode number as well, right? F clock by mode number, f clock by mode number. But if you take the larger bits, like number of bits equals to 5 or 6, then this can change. I guess this can change as well. Like this, for this it is certain that this will be f clock by mode number only, and this can also change. This can also change. So what is the conclusion? In n bit binary ripple counter, that means it will go from all the way 0 to up or all the way down. All the values will be there, all the states will be there. If all the states are there, then certainly this will be your f clock by 2. This, what we have applied is f clock. This will be f clock by 2. This will be f clock by 4. In that manner, what will be my last one? F clock by 2 to the power n. And here it would be f clock by 2 to the power n minus 1. F clock by 2, 4, 8, 16, 32. In that manner it will go. So if 10 are there, if 10 asynchronous binary counters are there, and if they are asking what will be the frequency of this one, what you will say? F by 2 to the power n, right? That would be f by 1204. Say yes or no, right? Let's see this one. If this is f clock, then certainly for this one it would be f clock by n, not 2 to the power n, f clock by n. Mode n counter it is, mode n, and this is mode 2 to the power n. So this would be f clock by n, but we are not sure about these. So here I will write cannot comment, can't comment. But for the final one, it is certain that it would be f clock by n only. But for these, we cannot comment. Are you getting this point? So if I say I have designed a mode 10 counter using 4 flip-flops. So what will be the, this is your MSB, and this is certainly your LSB, where the parent clock is there. Here parent clock is there, and this will be your MSB. So if I ask you, I have designed a mode 10 counter, what will be the frequency of my MSB count? What will be the frequency of my MSB count? That will be f clock by 10. I have designed a mode 16 counter. Mode 16 counter is 2 to the power 4 only. That means if you have designed mode 16 counter, that certainly it is a binary counter only. So what will be the frequency? F clock by 16. Okay. So let's solve a problem. Very simple problem. A mode 4 counter is made using 3 flip-flops. If clock frequency is f clock, then what will be the frequency of the waveform of MSB bit of the counter? Do not skip this part. Okay. Write down your answer and your answer will be wrong. If you have written f clock by 4. So blindly you have written, right? This is what? This is your mode 4 up counter. So how you would be going? Mode 4 up counter. Using 3 flip-flops. Using 3 flip-flops, right? There are 3 flip-flops. So 0, 0, 0, 0, 0, 1, 0 1 0, 0 1 1, then again 0 0 0, right? This is mode 4. This bit is not even used. For getting 4 states, how much flip-flops you need? 2 flip-flops only now. For getting 4 states, how much flip-flops you need? 2 flip-flops. This is not even being used. This is not even being used. Q2 is not even being used. So what is the frequency? That is equals to 0. It is always at 0 only. So this is not even periodic. So what is the frequency there? 0. So always first like keep your mind active whenever the question is coming. Although these kind of questions will not come, I just wanted to tell you that you should be attentive. Whenever you are studying, you should be attentive. That if they are saying mode 4, so 1 2 state, like I can think, okay, mode 4 I am going up. I would not even require Q2 bit. So Q2 bit will always be 0. So there you go. If it is always 0, so frequency is 0. It is not f clock by 4. You must have written f clock by 4. That mode 4 counter is there, so f clock by 4 for the MSB bit. No. You remember this one? But also remember that all bits should be in use. So here I am writing that all bits are in use. Okay. All bits are in use. So this is the point. All bits are in use. Here all bits are not in use. This is not even in use. If I had said I am designing mode 4 down counter. Mode 4 down counter using 3 flip-flops. Mode 4 down counter using 3 flip-flops, and initial condition is all are set. Mode 4 down counter, okay, using 3 flip-flops. Initial condition is all are set. 1 1 1, 1 1 0, 1 1 1 0, then 1 0 1, then again 1 0 0, then again 1 1 1. Here it like this was your 7 6 5 4. Here this bit is always 1, always 1. What is the frequency here as well? It is also 0. Say yes or no. Here this bit is always 1, this bit is constant, here this bit is always 0. So for mode 4 counter you require only 2 flip-flops. If you are using 3 flip-flops, then certainly the MSB bit is not even being used. That is constant. So frequency will be 0. So always keep your mind active. These kind of questions can come up in your examination. Okay then. So yeah, that's it about our asynchronous counter. There is one more topic left, that is concept of decoding the outputs. So we have these outputs, but how we will decode it? Using decoder. And what will happen if there is a delay in your asynchronous counter? If there is some delay in your asynchronous counter, then what will happen? How will you decode it? What will be the problem in decoding? And how to solve that problem? So that we are going to see in the next lecture. So the part of asynchronous counter is completed. We just need to decode it now. So that will be also for roughly around 30 minutes video. So yeah, that would be it. Okay then. Yeah, thank you very much.